Welcome to the Wastewater Treatment Certification Class webinar series, Chapter 10, Hazards, and the presenter for this chapter is John Walker. Working in a wastewater treatment plant, you are going to come across quite a number of different types of hazards. Because you're dealing with human waste, pathogenic organisms are probably going to be of primary concern, although the other hazards that occur should not be ignored. So let's have a quick look at what we mean by pathogenic organisms. These are any organism that has the potential to cause disease. We have viruses. This is an image of a virus. We should be all very familiar at this point about the role of viruses in causing disease. We have bacteria, causes disease like cholera and E. coli infections. Protozoa, diseases like Giardia and Cryptosporidium. We have fungi, although fungi tend not to be a major cause of disease in wastewater. However, it is possible if you are immunocompromised in any way. And finally, worms or helminths, things like pinworm and tapeworms. Again, usually these because of the way we treat water, both in drinking and in wastewater, these certainly in the West tend not to be much of an issue. Pathogenic organisms, we can be exposed to those through contact with the wastewater itself, anything that you might make from that if you are in a land farming facility, the sludge that you are going to collect and treat, but also here the foams that sit on the top of the water as the wind can blow them, and also any air droplets that come from the water, or if you've got an aeration system, the aerosols themselves can be a way to come in contact with pathogens. And of course, work surfaces, handrails, countertops, pumps, pipes, anything else that you're going to handle has the potential to transmit pathogen to you. Where do these pathogens come from? Well, not to put too fine a point on it, the bodily waste of infected individuals. Mostly we are concerned with human waste, although waste from domestic animals and wildlife also can provide pathogens. And the latest COVID outbreak might have illustrated the potential of wildlife to infect humans. Influenza is another one, and so on and so forth. How does that animal waste get into wastewater? Through I&I, storm events, leaky pipes, animals waste can get washed into streams, and so on and so forth. Slaughterhouse wastes can also be a way that potential pathogens can infect humans. And of course, there are animals that actually do live in the sewer systems, sewer rats, and of course their waste can also be a source of pathogens. In order to get sick, three things have to happen. The pathogens must leave the body of the infected individual. If they're not going to leave, they're not going to be transmitted to you. Those pathogens have to come in contact with a person or an operator, and they have to get into the body of the operator somehow. Those numbers of pathogens must be sufficient to cause an infection or disease. We are going to be somewhat differently susceptible to certain pathogens, either because we've come in contact with them before and we have immunity, or not. But one pathogen, one organism, one cell does not equal a disease or infection. It's usually going to be a lot more than that. The ways in which those pathogens can enter the body, first one is ingestion. You eat it, you drink it. This is also known as the fecal-oral transmission. You don't wash your hands when you go to the bathroom, or you drink contaminated water or food that has been washed in that water. And that's the easiest way to get infected. You can get exposed through breathing, inhalation, coughing and sneezing. Passes things into the air. And again, during this time of COVID, this is quite a serious way of getting sick. The last two, injection and invasion, are pretty much the same thing. That is where your skin, that covering that is impervious to most things, gets the barrier gets compromised, gets crossed, either deliberately through an injection or a cut, or any rash on the skin or abrasion. Even though the bacteria pathogens may not enter at that time, if they're open to the air, they could enter that way. So how can we reduce the risk of exposure? Well, good hygiene is really the best way of reducing your exposure. Hand washing, disinfecting of any surfaces that you come in contact with, cleaning any food preparation ways, cleaning surfaces, knives, things like this. Hand washing with soap is very, very effective. You really don't need antimicrobial agents in the soap, but they will destroy pathogens, but they also can do other unintended consequences also. So a good hand washing with soap and water for 20 seconds in warm water, sing happy birthday twice, you should be fairly well protected. Other than good hygiene methods, use protective equipment if you can. Certainly, if you're handling anything in a wastewater plant, you should be wearing gloves, probably eye protection. We all know about the requirement to wear masks now, but anything that will protect you from splashes or coming in contact with wastewater, and that should be provided by your employer, please use them and use them sensibly. And finally, common sense. If you know what you're dealing with in terms of waste water from toilets and so on, you don't go having your morning coffee over the aeration basin. There are ways in which we can get rid of potential pathogens. We call those disinfectants. And you can see here on the left-hand side a whole list of agents and chemicals that can be used and what they do to a pathogen, to reduce their potential ability to infect you. So alcohols, denatured proteins, alkalis in soaps. Remember, you make soap by mixing lye with fat, which is why if you get a drain cleaner on your hands, it feels very soapy because of the fat in your fingers. Detergents and soaps, again, can break the cell membrane open. Halogens, chlorine, iodine, bromine, these are great oxidizers, and we're all very familiar with the use of chlorine and to a certain extent iodine as a disinfectant. Heavy metals can be used, although when you're dealing with things like mercury and silver, there is a potential for toxicity. Ozone, hydrogen peroxide, as well as chlorine are oxidizing agents. And then phenol and phenolic compounds. Early soaps used to have phenol in them. And again, they damage cell membranes and denature and break down proteins, and then affect the pathogen's ability to survive and reproduce and grow. So again, these are the whole list of things that are available to you as a disinfectant. But soap and water is very easy to obtain, and get into the habit of washing your hands frequently. Of course, one of the things that common sense things is if you're handling anything, wash your hands before you touch your eyes, ears, mouth, and nose. I know it's very hard to do, but please get into the habit if you can, because it's one of your easiest and best ways of preventing getting sick. Don't eat, smoke, drink, or use any other tobacco product unless it's in a place where you are supposed to. And again, before you do any of those, wash your hands. Other things, keep fingernails short and make sure they're cleaned well with a brush, because dirt can collect under nails. We've talked about washing hands frequently and correctly. Hot soapy water for 20 seconds. Happy birthday twice. Use protective equipment when you can. And even if they're not required, if you've got any cuts or any chapping of the hands, you dealing in water out in the open, hands can get chapped, any rashes or anything like that, make sure you have protective equipment. We've talked about gloves, we've talked about goggles, we've talked about masks, because these are your first line of defense against infection. But hazards are not just pathogenic, they are physical objects as well. So hard hats and toe protected boots, uniforms are also ways of protecting you from getting sick or other injuries. So just to go through this very briefly, I'll allow you to read it at your leisure. But again, gloves, of course, make sure that if you've got gloves that you don't dip your hands into the water deeper than the glove goes up your arm. That's not going to do you any good. Make sure that your eyes are protected, not just for pathogens, but for anything else that might travel through the air and get into your eye. Masks, again, We are aware of their role in protection against pathogens, but there are other things in wastewater plants, certainly dust, that you don't want to be breathing in. So again, make sure that as you are operating in parts of the plant where protection is required, that they use it with the right training and use it properly. Anything that you wear as a uniform, make sure it's kept at work and that they are laundered at work. Don't take them home and wash them. You don't know what you're taking home. Ways of preventing infection or damage, injury, have things that are automatic. Bar screen cleaners, sampling. If you can get a robot to do it or a machine to do it, you're not going to put yourself in danger. Make sure you're going to use the properly trained sampling techniques. If you're in a confined space, make sure it's well ventilated, that you are trained, and that you are aware of every chemical that you are going to come in contact with. Every chemical that you buy should have a safety data sheet associated with it and should be kept somewhere handy in the office so you can refer to it. Make sure that there is a review of any accidents so that we can help improve training, reduce any potential dangerous situation. This may seem a little repetitive to you, but it's very important. Common sense, wash your hands. Every time you come or leave the plant, every time you have to remove gloves, and before you eat, you take a break. If you have to smoke or go to the restroom, wash your hands before and after you leave. We're going to move now from more talking about the pathogens, the biological hazards, to look at the chemical hazards. In a water plant, there might be areas, confined areas, that might not have enough oxygen to support your breathing and your life. There are hazardous gases. Hydrogen sulfide and chlorine are the two that you are likely to come in contact with, although there are others which we'll talk about later. And of course, in a wastewater plant, you're going to have the potential for the production of methane or methane, which is explosive. So what is a depleted oxygen environment? Well, the oxygen level of normal air is about 21%. Greater than 19.5% is required to breathe well. You can go lower than that, but it's certainly not recommended. So you really don't have a great deal of leeway between what we is in the air and what we need. It's only a couple of percent. The rest of the atmosphere is mostly nitrogen, and 78% or so, and the rest is trace gases, argon, carbon dioxide, and a few others. So before you enter any confined space, please check with a multimeter at least for oxygen, carbon dioxide, hydrogen sulfide, and methane. So don't go in and then switch the machine on, open the entrance or the manhole or the inspection port and check what's down in there. Don't assume ever that, oh, it's not that bad. If it shows anything, make sure it's ventilated before you go in. Other hazardous gases, we've talked a little bit about these, but these are often produced by anaerobic or facultative digestion of by bacteria. Ammonia, if you've ever smelt ammonia as a cleaning agent, you know it has a very irritating smell. Carbon dioxide, you can't smell, but it will put you to sleep and eventually kill you if the levels are high enough. Same with carbon monoxide. This is usually a result of insufficient, inefficient combustion. And again, is a colorless, odorless gas. And again, very, very dangerous. Great things about hydrogen sulfide is it smells. It has a rotten egg odor. But again, the levels that are safe are very low, and avoid it at all costs. Methane is not a toxic gas, but it removes the levels of oxygen, lowers the levels of oxygen, so it is an asphyxiant. You die from lack of oxygen, not too much methane. But the important thing about methane is it has a very narrow range of being explosive. So again, this is why you test for it with a multimeter before entering a confined space. Hydrogen sulfide is produced by bacteria that are growing in the absence of oxygen, anaerobic. If there is sulfur containing materials in wastewater, as they will be if it's poop, and of course, like anything else in biology or chemistry, things tend to be warmer in warmer months, temperatures, more production faster. So again, in warmer months, there will be more hydrogen sulfide produced. Just as an interesting sidebar information, has long retention times in lift stations and force mains. And it is important to remember that hydrogen sulfide can dissolve in water, and you start mixing it up, and that hydrogen sulfide expands into the air, and the concentration becomes much greater, which is again why anytime you go down a manhole or a lift station, make sure you test for the production of these, the presence of these gases. It is explosive, but it has a wide range between its lower and its upper explosion limit. It is, you can smell it at very, very low concentrations, 0.03 parts per million or 30 parts per billion. But above 50 parts per million, it actually physically switches off your ability to smell the gas. It's not that you get used to it. It actually switches off the nerve impulses to the brain that say, oh, there's this gas present. Notice that odor recognition at 50 is half the IDLH, or the immediate danger to life and health level that the OSHA recommends. So if you walk into a space and sniff and go, oh, I smell hydrogen sulfide, oh, it's gone. It probably hasn't gone, and your level's above 50, and it might be even higher than 100. It has a high specific gravity. It sinks. It stays at the bottom of something. So you might open it up and go, oh, it doesn't smell. You get to the bottom, at the bottom of a ladder, you smell it a little bit, then you don't smell it and you think I'm fine, all of a sudden you're dead. And there are too many YouTube videos out there showing the tragic instances where people have not taken the right precautions going into places where hydrogen sulfide is present. Where do we find hydrogen sulfide? Again, anywhere where there is water, sewage that can be anaerobic. So manholes, any low spots because it's a sinker, lift stations, gravity thickeners, and so on and so forth. Anywhere where you might have anaerobic conditions, hydrogen sulfide has the potential to be produced. One way to also see if it might be present is to look for corrosion. Hydrogen sulfide, when it dissolves in water, makes sulfuric acid. Sulfuric acid corrodes metal and concrete. So if you see a lot of corrosion, you know at some point that hydrogen sulfide has been present. Methane, this is, don't worry about all these numbers, with the exception of the lower explosive limit and the upper explosive limit of 5% to 15%. As I said, it's an asphyxiant. It's not toxic to you, but it does replace the oxygen. So again, even if you don't have a methane meter, which you should, and your DO meter has to read greater than 19.5% oxygen to be safe to enter. That's what happens if you have a spark and the methane is between these levels. It goes boom. This is just really for your information. This data is from the CDC NIOSH website. And this is just to show you, here we have hydrogen sulfide at 100 parts per million IDLH. Notice how low chlorine is, hydrogen cyanide, but the upper levels of carbon monoxide and carbon dioxide. Okay. Again, these two gases in confined spaces are also extremely dangerous. If any of you remember Apollo 13, you'll note the great scene where they are suffering from carbon dioxide effects, and they have to fix it if they're going to make it back. This ends the hazard section, chapter 10 of the wastewater treatment certification series. As every time we do this and we come to this point in the presentation, we give you two ways to contact us, either by email at envhelp@ky.gov or by phone 502-782-6189. And we would really encourage you, if you have any comments or questions, to contact us so that we can help you. It's our job to make this useful for you, and we don't want you to struggle. So use either of those ways to ask questions or offer comments about what we present to you. Thank you very much.